right, so in this lesson, we're going to talk about how different numbers put into an equation can transform the graph of a parent function. So if I multiply by a number, if I add or subtract numbers somewhere, if I multiply by a negative, how does that affect the graph of my function? So the graph of f of x equals x squared for the domain -2 to 2. So if you look down here, we see we have the graph of f of x here in blue. All right. And then they're only wanting us to graph from an x value of -2 to an x value of +2. Notice, because of these brackets, we are including the -2 and the 2. Also, if you will notice right there on your graph, we have those closed circles. So the graph of g is the graph of f after we have translated it 3 units down. And then how are the functions, domains, and ranges of f and g related? So when we move something down, that is a vertical motion. And when we think about like a point on a plane, the x value moves your point left and right, and the y value is where you go up and down. So if I'm adjusting and moving down, then I'm adjusting my y. Well, if you think about an equation, if we're in function notation, we always have like f of x. And then f of x might be equal to something. Okay? This represents the y. Okay? And y is equal to all of this. So in your mind, when it says we're going to move down 3, you need to think that's a y value. So I'm going to take my f of x and subtract 3. The same thing would happen if I wanted to move it up 3, then instead I would say plus 3. Okay? So let's say that I have a point here. I can move that down 3 just by taking that point and counting down 3. 1, 2, 3. And now I have this new point. So I've moved all of these points down 3, and now my equation has moved down 3. All right? The domain is still the same. I didn't move left or right at all. All I did was move up or down. So my domain is still going from that -2 to the +2. But my range is now 3 lower than it was. Before, my range was 0 to 4. So now instead it's dropped down 3, so now it's -3 to +1. All right, now there's other types of transformations like reflections and stretches and compressions. All right, but in general, if we're thinking about a vertical translation, then that just means that we're going to take our f of x and add a number, or take our f of x and subtract a number. Okay, so the graph of the function f of x equals x squared for the domain -2 to +2. This is exactly the same graph that we had a while ago. So I am just going to plot those points on here. And draw that in. So there's the graph of x squared. It says the graph of the function g is the graph after a transition of 3 units to the right. So now we're not moving up or down, we're moving right, which is a horizontal motion. All right, so that means that we need to take our function f of x, and we're going to take the x value, and we're going to subtract 3. Now you might say, why are we subtracting 3? I thought that we needed to add 3 because we're moving right. Anytime we adjust something horizontally, it's going to be the opposite of what we think. So if it looks like we should put a plus, we really should put a minus. So I look at my equation. My equation is x squared. So in place of x, I am now putting x minus 3. Now, if this would have said, let's move to the left 3, then this would be a plus instead. Okay? But that's not what we're doing. Now, I could go to my calculator and plug in this equation, go to the table, and just plot those points that go from an x value of -2 to +2. However, it wouldn't be correct because I have shifted to the right. So I'm not at -2 anymore. I am now 3 to the right of that, which would be +1. And I'm going to show you that this is true. If I took each of these points and moved them, so let's say I took this point and I moved it 3 to the right. 1, 2, 3 to the right. If I took this point and moved it 3 to the right, it would be here. 3 to the right. Take this next one, move it 3 to the right, and then take the vertex and move it 3 to the right. All right, now I'm here. So my domain is now from 1 to 5 because I moved 3 to the right. All right, so my new equation is g of x is equal to x minus 3 squared. Okay, the domain is different, but the range is the same. I didn't go up or down. It's still 0 to 4. All right, so if we compare the intercepts of f to the intercepts of g in part A, my intercepts are different. So if you look at the graph of f, my y-intercept was here at 0, and so was my x-intercept. Now when I shifted down, now my y-intercept is -3, and my x-intercepts are between 1 and 2 and -1 and -2. All right, if you look at part B, all right, my x-intercepts have also changed, and I don't even have a y-intercept. It doesn't cross anywhere. So if I'm looking at this, my x-intercept was 0. Now my x-intercept is 3 because it's 3 to the right. And again, since I restricted that domain, I don't even have a y-intercept for my second graph. All right, so the graph f of x equals 2x minus 6 for the domain, so x values from 0 to infinity. Notice we are not including 0. We should have an open circle there when we graph. And the function g, whose graph is a reflection of the graph of f across the x-axis. How are their functions related? All right, so first let's graph the 2x minus 6. Now again, I could take this equation and I could go to my graphing calculator, plug that into the y equals, and then go get some points from the table. Or I could just realize this is linear. So I'm going to start with a y value of -6. So -6. I'm going to put a dot there. All right. And then I realize that my slope is 2. So I'm going to go up 2 and to the right 1. Now, I made a little error right there. That needs to be an open circle because remember, we're not including when x is 0. So make sure that's open. And then I'm going to give myself a couple more dots. I'm just going to keep going up to right 1, up to right 1, so that I have a good guide for drawing this line in. And then it says it's going to keep going on forever. So I'm just going to draw that line in. Now, it tells me that it wants me to take this and reflect it across the x-axis. Well, let's think about this. If I reflect something across the x-axis, that means that if I have a point down here that is 4 below, then that means that if I reflect it across this axis, I would have a point up here that is 4 above. Or here I have a point that is 2 below, so I would have a point 2 above. All right, this is on the axis, so it literally stays there. This point is 2 above, so I would have a point 2 below. This point is 4 above, so I would have a point 4 below. And then here I have that open circle at -6, so I would have an open circle at +6. All right, and then I could just draw that in. I have reflected this graph over the x-axis. But when I'm thinking about an equation and how I can adjust my equation to show the equation of this, red line that I just put on here, okay, I have to think, well, when I go across the x-axis, that's vertical. Like I have points down here and a point up here, a point down here and a point up here. So this is a vertical thing. So that should adjust my y value. Remember, y is the f of x. So I need to take a negative times my f of x. Well, f of x is 2x minus 6. So I need to take a negative 1 times 2x minus 6. When I do that, I get negative 2x, distribute that negative to the negative 6, and a positive 6. It also told me to call my new equation g of x. Now, if I graphed this one, I could graph this in my calculator. I could do it by hand. I have a y-intercept that's not included up here at negative 6. And then my slope is negative 2 over 1. So down 2, right 1. I already have my point there. Down 2, right 1. I already have my point there. So when I adjust the equation, if it's across the x-axis, it should be a vertical motion. So I'm going to adjust my y value, my output. Okay? Now, what do we do when we want to go across the y-axis? Okay, we're not actually going to graph this one, but if I have a point here and I go across the y-axis, that means I have a point here. That is a horizontal motion. So that negative 1, instead of being multiplied by the y value, needs to be multiplied by the x value. So I'm going to take my function and multiply the x by a negative 1. So if I took that equation, I would have 2 times negative 1x minus 6. Then I'm just going to simplify. 2 times negative x is negative 2x minus 6. And there is my equation that is reflected across the y-axis. So to reflect across the x-axis, a vertical motion, I will take a negative 1 and multiply it times my entire equation, because that's what my y is equal to. If it's across the y-axis, that is a horizontal motion, I will multiply the negative 1 times just the x. All right, so let's do this algebraically without even looking at a graph. We have x squared minus 2. They want us to reflect that across the x-axis. That is a vertical motion, so I'm going to take a negative times my function f of x. This is my f of x. So negative times x squared minus 2. I'm going to distribute, and I'm also going to name this g of x. It really doesn't matter. You can name it g of x, h of x. Those are the most common. So now I have a negative x squared and a positive 2. So there's my equation for a reflection in the x-axis. All right, so for part B, it's a reflection in the y-axis, which is a horizontal motion. So I'm going to take my function and just multiply the x by a negative. So that gives me a negative x squared minus 2. Parentheses are very important here. Now, if I take a negative number and I square it, it will always come out to be a positive. So I'm going to simplify this to x squared minus 2, and let's just call this one h of x. All right, so we have the graph f of x equals the absolute value of x. So again, absolute value of x, and we're going from negative 4 to positive 4. Negative 4 and positive 4 for the domain are included, so we'll have those closed circles at the end. Again, if you don't know how to graph the absolute value function without a calculator, you can plug absolute value of x in and graph that. Just make sure that you go from negative 4 to positive 4. Now they're asking me to take 2 times f of x. Now remember, f of x is my y, or my entire equation that I have. Okay, so when I do that, I know that that's going to be something that has to do with a vertical motion. All right, so if I take 2 times f of x, if I take 2 times f of x, I know that f of x is the absolute value of x. So 2 times the absolute value of x. That gives me my g of x. Now, I could, if I wanted, I could go to my calculator, plug in 2 times the absolute value of x into the y equals, go to my table, get the points. Or I could also give it some thought on my graph, since I'm graphing this. I know that this is 2 times my y values. Well, look at your y values here. We have this point right here, which is negative 4, 4. I have this point right here, which is negative 3, 3. Okay, so on and so forth. And I'm adjusting my y value. So 4, if I take that times 2, because that's telling me what to do, now I have negative 4, 8. If I take this times 2, negative 3 times 2 is 6. Notice I'm not changing the x values. 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. Now when I plot these points, I have negative 4, 8. I have negative 3, 6. Negative 2, 4. Negative 1, 2, 0, 0. And then these are just mirrored across because that would be your axis of symmetry. Now, if I look at this, my y values have been stretched up. All of them are twice as high as they were. We call that a vertical stretch. So this was a vertical stretch by a factor of 2. So anytime I want to have a vertical stretch, I'm going to multiply my entire equation by whatever number I am looking at. In this case, it was 2. All right, now a vertical stretch is also the same thing as a horizontal compression. All right, so what I mean by that is instead of viewing this as an upward motion, you could say, well, horizontally, my numbers went inward. They compressed. Now, since I already know that this 2 was affecting my y value, I will describe it as a vertical stretch. Okay, but it could also be known as a horizontal compression, depending on how you're looking at it. All right, so we're doing the same thing here. We have that same equation. All right, the absolute value of x still going from negative 4 to 4. And again, if you're not good at graphing things or doing that by hand, use the tools that are given to you. So here's my absolute value of x. This time, though, they're asking me to do the 2 times x. So it's not on the outside like in the last problem. It's on the inside. So I'm going to take my f of x and I'm going to plug in 2x instead. So since this is f of x, the absolute value of x, I'm going to take absolute value of 2x. Now remember, things that are horizontal are different. Okay, so I'm not going to multiply x by 2. I am going to multiply x by 1 over 2. I'm just flipping this, okay? Either that or you can view it as dividing by 2. Multiplying by 1/2 or dividing by 2 are the exact same thing. So let's look at these points. We already know from the last question that we had the point negative 4, 4, negative 3, 3, negative 2, 2, negative 1, 1, 0, 0. So I am going to multiply these x values by 1/2. So, I can think of it what's half of negative 4. So half of negative 4 is negative 2. My y value remains the same. I did nothing to that. All I did was take the 2 times the x. All right. Half of negative 3 is negative 1.5. Half of negative 2 is negative 1. Half of negative 1 is negative 1/2 or negative 0.5, however you want to view that. And half of 0 is just 0. Again, my y values did not change. So when I graph these points, I have negative 2, 4, negative 1.5, 3, negative 1, 2, negative 1/2, 1, 0, 0, and then again, you can mirror that over here to the other side, so it makes your V shape. And if you look, again, this made your Y values push inward. They got closer together. So we consider this a horizontal, compression by a factor of 2. All right, so remember, if it is horizontal, if that number looks like to you that it needs to be a stretch, it is not going to be. It's going to be a compression. It's always the opposite of what you think. All right. Now, just to kind of reiterate what we have here, if we have a vertical stretch or compression, that's when I take a number and I multiply it times my entire function, or the Y value. Okay. If that number is bigger than 1, it's going to be a stretch. If that number is between 0 and 1, it will be a compression. So numbers between 0 and 1 would be fractions that are bottom heavy. So like 1/2, 1/3, 2/3, but not like 4/3 because that's bigger than 1. Okay. When we have horizontal stretches and compressions, that's when I multiply just that X value. If it's between 0 and 1, that will be a stretch. But if that number is bigger than 1, it will be a compression. All right. So using this graph, how can we graph a combination of transformations? So let's take a look at that. So we have the f of x over here. They are telling you that because it's, literally graphed in blue over on your graph, okay? And they're wanting us to do things with this function, all right? So if we look down here, they want us to graph y equals negative f of x plus 2. So normally I just have f of x. All right, but now we've added this negative in front, and then we've also taken inside here and we have added 2. Now, if I'm looking at this, I can tell just by looking at it what I'm going to be doing to the graph that I have over here. All right, so first off, I see that inside here I have x plus 2. I am adding 2 to just my x. If it was on the outside, like this, that would mean up or down. But because it's on the inside, it means left or right. Now remember, we like to think that positive is right, so it looks like we're going right 2. However, we are not. We're going left. So I know that I'm going to have to move left 2. Okay, I also notice that on the outside, I am multiplying my entire function by a negative. That means that I have a reflection. Since it's with my y, that's a vertical motion, so it should go over the x-axis. Now, which one do we do first? You should go with order of operations. Order of operations tells me that I should do what's in the parentheses before I do what's on the outside. So first things first, I know that I have the f of x plus 2. We're going to kind of ignore the negative for a minute. That means that we're going to move 2 to the left. So pick some identifying points on here. So for instance, I have, this is the end, and this one over here is also the end. And then I have like a high point and a low point. I'm just going to pick different points on here and move them. It's easier to move ones that are crossing like evenly at little, actual points, not decimals. Okay, so I'm going to move this to the left 2. So I'm going to take this point, I'm just going to move it left 2. And I'm going to take this point up here and move it left 2. All right, this point here, I'm going to move it left 2. And then the point way up here at the top, we're going to move it left 2. Now, I still have something else to do, but I kind of want to make sure, I still have the same shape. So I'm going to fill this in with dotted lines to show I'm not done yet, but, I want to make sure it still looks right. So it's the same shape. We've just shifted 2 to the left. All right, and then for the negative in front of our f of x, that means that we're going to have a reflection over the x-axis because that is being multiplied by my y value. All right, so if I reflect over the x-axis, that means that if I have a dot right here, it is 2 above the x-axis. 1, 2. So I'm going to put a dot 2 below the x-axis. Here, this is 4 above, so I'm going to put a dot 4 below. All right, this one is 3 above, so 3 below, and 7 above, so 7 below. And now I'm actually finished. I've done everything I need to do. So now I can connect it. And there we have it. So we moved left 2, and then we reflected over the x-axis. Okay, so now it's how can we combine transformations again. So we have 2 things on this one. If you look, we're adding 3, and notice that's not in the parentheses, which tells me that this is going to be a vertical thing since it's being done to my f of x and not just to the x. And then also I'm multiplying my f of x by 1/2. Now order of operations tells me that I should multiply before I add. Okay, so the first thing we're going to start off with is the 1/2 times f of x. Since that's done to my y, that's going to make this a vertical. Since it's between 0 and 1, that would be a compression by a factor of 1/2. All right, so I'm going to take my y values and multiply them by 1/2 or divide them by 2. So if I'm looking here, like at this point, okay, I have the same kind of points I want to move here, those little pointy parts and the ends. Okay, I could say, well, I'm up to 1/2 of 2 is 1, and just move that down to a y value of 1. If you need to list the point, this is -4, 2, just like we did on the other. I could say, well, 1/2 of 2 is 1. So now I have a point at -4, 1. Okay, I'm just going to half these points. So I'm up 1, 2, 3. This is 4 up. So 1/2 of 4 is 2. This should only be 2 up. 1/2 of 3 is 1/2. So this should only be 1/2 up. And 1/2 of 7, because it's 7 up, is 3/2. This should only be 3/2 up. Now again, I'm just going to fill this in with dots because we have other things we have to do to this. But as you can see, it did get shorter. Okay, it kind of compressed vertically. All right, now we have the f of x, and we're adding 3. That means we're going to go up 3 because it's on the outside of the parentheses. Remember, if it's on the inside, that's left or right. It's outside. We're going to go up or down. So I'm just going to take these points that I have and move them up 3. So 1, 2, 3. Take this one, up 3. This one, up 3. And this one, up 3. And now I am ready to connect those. And I'm done. All right, so just doing a couple more of these. So if you look at part A, I see that I am subtracting 4 on the outside of the parentheses. That tells me that that's going to be a down 4 motion. and I am multiplying by 2 on the inside, so I'm going to have some kind of horizontal stretch or compression. All right, since it's just the x. Now, order of operations dictates that I should do the f of 2x first. Now, remember, when you're adjusting just the x, that's something horizontal. So this is a horizontal. Now, since I'm multiplying by 2, I want to say that it's a stretch, but it's not because this is something horizontal. So I know that this is a compression or a shrink, okay, by a factor of 2. Now, because I'm doing the opposite, I know that I'm not going to double my x values. Instead, I'm doing the opposite, and I'm going to be cutting them in half because it's a 2. So instead of multiplying by 2, I'm going to multiply by 1/2. So again, if you need to write down these points and then multiply your x values by a half, you can do that. I'm just going to half them. So I have an x value of -4. Half of that is -2. So now my point is shrunken in a little bit. All right, this has an x value of -2. Half of that is -1. So I'm just going to move that over to an x value of -1. Remember, my y's are not changing. Not right now. All right, I have this point, which has a an x value of -1. Half of -1 is -1/2. And then this has an x value of +1. So I'm going to put that at a +1/2 x value. So I have compressed that horizontally. In other words, all these squished inward. Okay? So next I have the -4. So I'm going to take my f of x and subtract 4. That means I'm going to go 4 units down because it's on the outside. So I'm going to take all of these points and move them 4 down. So move this point, 1, 2, 3, 4 down. Move this point 4 down, 1, 2, 3, 4. Moving this point 4 down, 1, 2, 3, 4. And this point as well, 1, 2, 3, 4 down. And now I'm ready to connect it. All right, so taking a look at part B. This time I have 3 things. This is on the outside, so I know that's down 2. This is on the inside with the x, so I know that that's right 3. And then again, I have that horizontal compression by a factor of 2. So again, we have to start with the parentheses because that's what we need to do first. And inside the parentheses, we're multiplying by 2 and subtracting 3. So first we're going to do that compression. So let's start with the 2x. So we have a horizontal compression by a factor of 2. All right, so we can do exactly what we did up here. We're just shifting all of those. We did this on the previous problem. It's the first step that we did. Then we have to take that f of x minus 3. So we're going to take the -3. Now I know that since I'm subtracting 3 inside the parentheses, that really means I'm going to go 3 to the right. Now I could take all of these dots and move them 3 to the right, but I also know I'm going to move 2 down because I have f of x minus 2. That -2 is on the outside. So I really could do this all at once and go 3 to the right and then 2 down. So 3 to the right and 2 down. And we'll just adjust all of those. 1, 2, 3, 2 down. 1, 2, 3, 2 down. And 1, 2, 3, 2 down. And then I have my graph. Okay, so we are given a picture over here of F, G, and H. So obviously there were two things that were done to this. It just wants to know what transformations of this is a different equation than what we've been looking at, results in the graph of the function g. All right, so here's the deal. We already have an x squared, but now we have this 1/3 in here, and we also have this negative. All right, so that tells me that two things contributed to the shape of this, graph of g. Well, I know that if I take a negative and I multiply that on the outside of the parentheses, not in there with my x, that's going to be a reflection in the x-axis. That's because it's affecting my y, and that's a vertical motion when we go across the x-axis. I also know that when I multiply inside the parentheses by a number, that's something horizontal. So we have a horizontal. Now, since it's 1/3, I want to say shrink, but I know that this is a stretch by a factor of 1/3. Okay, when I look at this one, again, I'm starting off with x squared. And looking at the graph, like the blue is the first one. Obviously, if we went from blue to green, that moved over to the right 4, and then from the green to the red moved up like 2. Oh, we're counting by 2s, so on the y-axis. So 2, 4, 5, okay? And if you look at your equation, we're adding 5 on the outside, subtracting 4 on the inside. That's the only thing that changed from our original function. So when we subtract 4 on the inside, that means it's going to move right 4. You could say translate right 4, and you could say move up 5. All right, so part A, we're starting with absolute value of x. I see that I've added a 3 on the inside, so when we add a 3 on the inside, that means we moved left 3. It's opposite. All right, and on the outside, we multiplied by a half, so that would be a vertical compression by a factor of 1/2. For part B, we added 2 on the outside and multiplied outside by a negative. So added 2, that means it moved up 2 because it's on the outside, so that's affecting my y. All right, and the negative is also on the outside, so that would be a reflection in the x-axis, or over the x-axis, however you want to state that. All right, so we have a scenic train ride that's making a trip on an old mining line. The graph shows the distance y in kilometers of the train from the station x minutes after the ride begins. What equation represents the distance from the station as a function of time, and what is its domain? So we don't have an equation here. That's what they're asking us to find. So we already know that the y value represents the distance from the station and the time since it starts. Okay, so at 0 minutes, we are 0 from the station, and at 30 minutes, we are 0 from the station. All right, so apparently we made a trip, and we came back. It also took us 15 minutes to reach wherever our destination was. Okay, so we need to write an equation for this graph. Now, I know that we have some sort of reflection in this graph from a normal absolute value. That's because absolute value starts at the center and comes up like this. So I know that somewhere along the way I'm multiplying by a negative. And since it's a reflection upside down, that means it was over the x-axis. So I know I need to multiply negative times my whole equation. All right. Now, if I write an absolute value equation, it's y equals a times the absolute value of x minus h, and then plus k. All right, we always put a minus right here because it's always opposite of what we really think. We've talked about that multiple times. The H and the K represent your vertex. H comma K. So if this was 4 and this was 5, so I had x minus 4 and then plus 5 back here, my H would be 4 and this would be 5. That's because even though this looks like negative 4, it's in the, it's in the equation that there is a negative there. So if this was positive 4, then this would be negative 4. Okay? All right, so we know that the graph shows the distance in kilometers from the train. I do know my vertex, okay? My vertex is that high spot right there, and they actually named it for me. It's 15, 15. All right, so I know that I need a 15 here, and I need a 15 here. So I have y equals, I don't know what this part is, okay? So we're going to leave it alone for a minute. And then we have x minus, and then we had a positive 15, so that goes here. And then plus, and then we have 15 here. Okay? Now, I do know that I need to multiply outside by this negative. I don't know what that is. So I'm going to put a negative with this number. It's a negative because I'm doing a reflection over the x-axis. Now, to write this equation, I have to know what a is. Like, I can't have 3 variables. I just need a y and an x. So I need to solve for the a. All right? Now, how am I going to do that? Well, I need a point that is on my graph somewhere. So I could use 0, 0. I could use this 30, 0. It looks like, 6. 6 is a good point maybe, but the easiest one to use would be 0, 0. So when y is 0 and when x is 0, I can't solve for a unless I have something plugged in for x and y. I can't solve unless I have one unknown. All right, so I'm going to just start solving this. So I know that 0 minus 15 is negative 15. And then I have to take that times this, the absolute value of negative 15 is positive 15. So times negative a would be negative 15a plus 15. Now it's a simple solve for a. So I'm going to subtract the 15. Oh, don't ask me why I put that there. That's a 0. So I have negative 15 equals negative 15a. Divide by negative 15. So a is 1. So the equation would be y equals. Now, I'm not going to put a 1 there, but I do need the negative because I know that I have to have the negative. It's upside down. So negative x minus 15 plus 15. Please don't write the 1 there. We know that it's there already. Okay? Now, how would the graph and equation be affected if the train traveled twice as far in the same amount of time? Well, travel, that would be your y value, right? Well, if we adjust the y value and it's taking us twice as far in the same amount of time, that's going to be a vertical stretch. So let's think about that. Everything would be stretching by a factor of 2. So that means I have to take 2 and multiply it times everything that I have. Well, right now what I have is negative absolute value of x minus 15 plus 15. If I take everything times 2, that would give me negative 2 absolute value of x minus 15 plus 30. All right, so just kind of a summary of everything. If I'm wanting to do a horizontal translation, 2 to the right would mean that I would subtract 2 with just the x. 2 to the left would mean I would add 2. If I'm doing a vertical translation, I'm just shifting up or down. That's going to go on the outside where I add or subtract to my whole function. All right, a reflection, if I'm reflecting across the x-axis, that affects my y value, so negative times everything. If it's across the y-axis, that affects just my x. So negative times the x value. A horizontal stretch, that would mean that multiplied by my x is a number between 0 and 1. All right. A vertical stretch means I'm multiplying everything by a number bigger than 1. All right. And then also we should say that a vertical stretch, all right, would be, or a vertical shrink would be if I multiplied everything by something between 0 and 1. And a horizontal shrink would be if I multiplied just that x value by a number bigger than 1. All right, hopefully you got something out of that, whether it was clarity or just a refresher.